If you're running online conformal prediction across multiple confidence levels, you've probably noticed a frustrating quirk. The prediction sets stop being nested. Run the quantile tracker independently for alpha equals 0.1, 0.2, 0.3, and you'll get crossing intervals. That's mathematically incoherent and practically useless for risk management. A recent paper by Ochoa Rivera and Tewari fixes this by framing multi-level online conformal prediction as a joint quantile estimation problem, solved through constrained online optimization. Instead of updating each threshold separately, they reformulate the standard quantile tracker as an online mirror descent step, minimizing a joint pinball loss across all coverage levels. The key innovation is enforcing monotonicity directly in the update step. First, exponentiated gradient. They parameterize the quantiles as cumulative gaps over a truncated simplex, then apply a KL projection that redistributes mass globally across all levels whenever miscoverage drifts. Second, projected gradient descent. They take standard gradient steps on each threshold, and then project the entire vector onto the cone of decreasing sequences using the pool adjacent violators algorithm. Unlike EG's global coupling, PG applies local corrections, but both strictly enforce monotonicity by construction. Theoretically, they bound the dynamic regret of these updates, which directly translates to controlled quantile tracking error and long-run coverage guarantees. Empirically, on both a non-stationary synthetic random walk and real U.S. inflation data, the constrained methods maintain strictly nested prediction sets while tracking time-varying quantiles with significantly lower estimation error than independent trackers. The EG variant, in particular, shows smoother calibration dynamics because its global coupling prevents the oscillatory overcorrection common in standard quantile tracking. If you care about distribution-free uncertainty quantification that actually behaves like a proper risk spectrum, this joint optimization perspective is the way forward. Check the paper for the full dynamic regret proofs and projection derivations.